The topic was already perfectly framed by our moderator. And I'm very happy today to welcome a panel of experts where we're going to talk about different real cases, how autonomous things have been deployed in production in factories and warehouses. To my left, I welcome Joydeep Akaria from Hitachi Americas, Luke Corbett from Cipher Robotics, my colleague Alan Minney from Ericsson, and of course Joan Tomic from Slalom Labs. And as we see more and more connected autonomous things rising in the factory environments and in the production, we see these intelligent machines, of course, that encompasses AMRs, drones, but also other intelligent devices. We see those being able to do advanced tasks which weren't possible to automate before, and augmenting human capabilities towards more lean and efficient production. And my first question goes to my colleague Alan. What are the key benefits that you see that manufacturers can achieve through investments in those autonomous things?
So I think when you look at these benefits, we also think about them as opportunities. And so there are opportunities for increased efficiency. Your plant operations can run more smoothly. Increased safety, improved safety. Maybe you have hazardous conditions where you want to protect workers. And so this allows you to not put them in harm's way. And then enhance quality control. You can do things like autonomous inspections, again, reallocating those workers for other tasks. And then finally, it's a really good opportunity to reduce cost. As your operations improve and become more efficient, that's going to drive cost out of the plant operations and out of the business.
Great. And I think one thing is very often overlooked in all of these efforts to automate, utilizing smart things and latest technologies like industrial AI models, etc. And that is, how are these things connected to each other? How are they connected to the factory itself? How are they connected to the warehouse? And I think it requires a really superior, stable, reliable infrastructure, wireless infrastructure, to support all of these activities. And what is advanced connectivity? Why is it so essential for making these things happen, for deploying autonomous things and driving to the next level of automation?
So it's a great question. I would say that as you're thinking about employing these types of autonomous devices and solutions within your environment, it's really, really critical that you have a network that is high speed, low latency, very secure, very reliable. That's absolutely critical. Secondarily, legacy network infrastructure has its uses and its purposes, but it's also not really designed for a super dynamic environment, a kind of a modern factory, if you will, where you've got to connect a lot of devices, a lot of sensors, you're pushing a lot of data, you're connecting to your cloud infrastructure. And so, fundamentally, we see that, this 5G technology allows a lot of that flexibility, scalability, and allows you to, again, really modernize your operations.
That's great. I'm switching to the first use case here, and that is about inspections. Inspections is, of course, critical for ensuring quality of the output goods, and it's an essential part of factories' operations, and that goes across industries. So recently, Hitachi Americas, Ericsson, and Slalom collaborated on a proof of concept for inspection in the factory of railcars, using quite advanced technologies like the robotic dog Spot from Boston Dynamics. And my first question goes to you, Joydeep. What business challenges were you trying to solve, and what that brought you about your collaboration with Slalom and Ericsson?
Yeah, just to give a bit of a context, Hitachi is very big on railways globally. And even in the United States, we make metros for Honolulu, Baltimore, and most recently for Washington Metro. So we opened this brand new factory in Hagerstown to produce rail cars. And then we also saw it as an opportunity to really make it a truly digital factory, as we like to call most advanced digital factory, where we'll have all kinds of robotics and automation technologies. And one of the key things, as you mentioned, Jan, is end-of-line inspection of the rail cars. And it can be an incredibly complex challenge because we are talking about a variety of potential defects, like scratches on the paint, checking the gaps between panels, looking if a certain wire is missing in the undercarriage area. And again, it could be inside the car, on the roof. So it's pretty challenging, and what we really want to do is improve the efficiency of this process. And again, efficiency is like twofold. One is how to increase the speed. So in the beginning, we were producing cars for Baltimore, and that was about like 20 cars a month. Now at Washington Metro, we have to scale it to like 3 times more. So we have to do it fast. And the other is do it reliably. So any kind of inspection that human beings do is incredibly subjective. What may be a scratch to a novice worker may not be a scratch to an experienced worker. So how do we tackle this issue? So yeah, this is, I would say, improve the efficiency of operations. Inspection is the key challenge that we are looking to solve with these advanced technologies.
Yeah, that's great. I would say that is one challenge containing a number of challenges. And let's look at the solution that was then built for tackling this specific challenge together with Slalom Labs. And John, a railcar is quite a difficult object to inspect, of course. Can you tell us a little bit about how did you approach this complex task for quality inspection?
Sure thing, Jan. So a train car is a really complicated object to try and do this type of inspections on. Excuse me. Sorry, I took an early morning flight here. And so I think, first thing, you need something that's very dynamic. And having a autonomous mobile robot that can actually walk around and my friend is here now, actually. So he's. I think he brought you. I need my water bottle here. Thank you, Spot. So actually, stay right here. So this is what we used. This is what we used in the factory to run the inspections. And basically, what we needed was a platform that was extremely dynamic and basically a walking sensor. So the ability for it to walk around a complex object that was not necessarily in the same space, the same spot all the time was critical. The camera technology that's on the robot itself was critical for what we were trying to do. We were using sensors like pan-tilt zoom 360-degree cameras. We were using LiDAR scans. We were using thermo cameras to look for the scratches, the dents, the tolerances between the door frames and the windows. And that's the type of solution that we needed to solve a problem like this. It was kind of a mix between having this intelligence built into something that was mobile, and then something that was robust and had enough sensor technologies to be able to do the job itself.
Ah, that's great. And I guess you also had to solve some integrations with the existing factory systems, right? Like.
Yeah, it was so one of the things, one of the reasons why we used Spot, which was very critical, was the amount of compute that was required to actually run the analysis on the defects. It was a balance between what to operate on the robot itself versus what to offload and then run using computer models. So what we did in the factory with Joy's team was we were using the robot as the collector of information, leveraging the 5G network that it was connected to, offloading the data over to the servers so that it could run the models. And that did a couple of different things. One, it balanced the compute that was sitting on the robot versus what was offloaded on the robot to put the right job, the right task to the right job, and leverage the network to do things like controlling battery power as well, which is critical.
Perfect, cool. So then Joy, from your perspective, what role did the 5G network play in this context overall? I mean, you could have had the dock coming into the bay, offloading its data, going back again, or can you tell us a little bit about your motivation of what made you choose 5G for that?
Definitely. I mean, it's a big factory, and any kind of indoor connectivity is really challenging in terms of Wi-Fi. We tried before, it didn't work. And we really needed something which can connect different parts of the factory. For example, it's a new factory. So initially, the inspection station was located in one corner. And later down, they figured out for logistic reasons, they need to move to another one. So we want, and that's the prerogative of the folks who designed the factory. And we wanted them to be able to provide a network which can always provide connectivity, no matter if the stations change, the layout changes. And we really felt in terms of 5G connectivity is really good. And again, one main thing on 5G which I really feel is good is the scale it provides, because Hagerstown is one factory. If tomorrow we open a new factory somewhere else, it's much easier to port a solution, I would say a 5G plus cloud solution which provides this kind of an ML application to a new factory if it's over 5G.
Great. I think that's a real innovative approach, merging a number of state-of-the-art technologies together to solve a problem. And you already mentioned a number of the outcomes of that proof of concept. If you would have to put the key benefits into like 3-4 bullet points, what would you say is that?
Yeah, that's a great question. Like I would say, like I initially mentioned, we are really looking to improve the efficiency of inspection. And efficiency, as I mentioned, is speed and reliability. So in terms of speed, we have been able to offload a lot of the inspection tasks to Spot. So it's not all inspection possible. It's a robotics solution, but we have this working parallelly with the human inspectors, often maybe doing it at night when the factory is closed. So that way we're able to parallelize the inspection operations. And in terms of reliability, as I mentioned, what qualifies as a scratch or a dent or a bump. So that subjectivity has been taken away. So we have a very standard precision now where, as John mentioned, Spot takes lots and lots of images, and we have the expert, the domain expert have them annotate just once, and after that, it's a standardized process. So we have the results exactly as per desire, taking away any human subjectivity.
Perfect. I really like that case, and I think the spirit it was built in was fantastic. That's what I heard. I was not part of the team, but it was a let's do it spirit, and that's the nice thing. If once you have an, let's say, underlying platform you can work on, you can basically do everything. That's great. But talking about standard tasks, I would like to switch to Luke, and we're going to talk about the, let's call it cumbersome and high-effort task of inventory cycle counting in a warehouse. That's also something that people really struggle to automate over years and years. When drones came up, everybody said, yeah, you can do it with a drone, fine. No one succeeded in the beginning with that. But in spring, Cipher Robotics launched a solution called Captis. And Captis is solving the challenges that were experienced before. And maybe you can tell us a little bit about the approach and what Captis is capable to do.
Yeah, so Captis is solving the problems around inefficient, costly, and infrequent manual cycle counting. So what Captis is a combination of a ground robot and a drone. It's going to be autonomously deployed. It lives on site, wirelessly charging, comes out, goes down the aisle, and then the drone is basically flying a curtain along the shelf to scan for barcodes on pallets or QR codes on boxes, and ultimately turns those scans into data that can then be uploaded to the existing WMS system. This helps to have really accurate inventory counts, and it can kind of continue out through the entire facility and cover a really significant portion of the square footage in a single night.
I can imagine that this is extremely attractive to warehouse managers. Like, if you would talk to a warehouse, or if you talk to a warehouse manager, what are the key benefits you would describe as being core of the solution?
Yeah, absolutely. So because the system is autonomous and often deployed at night, aisles don't need to be shut down during the workday. So you can do this really manual process kind of overnight and not be burdensome to the workers trying to access the inventory. Beyond that, I would say there's kind of 4 prongs. It's cost, it's safety, it's time, and it's accuracy. So on the cost side, because a human doesn't need to be in the loop, those workers can be allocated elsewhere and do more productive tasks. And then the same can be said for the equipment that's often used for inventory counting. So things like forklifts, they don't need to be allocated to this task. They can now be allocated to other more productive tasks. Robotics, you'll often find, are used to kind of supplement the dirty and dangerous jobs that happen within warehouses or in manufacturing plants. So it definitely improves safety there. With some of our deployments, we've seen the robot drone combination can count inventory about 30% faster than a person can. So when counting inventory is a timely matter, it's really pivotal there. And then lastly is just the accuracy. So a robotic system isn't prone to human error like a lot of manual processes are today.
Perfect. But I mean, warehouses can be really, really huge.
Yes.
So what role did the private 5G system play, or does the private 5G system play in the deployments you're doing in that combination?
Yeah, 5G I always look at as like the enabling technology, not just for Captus and our solution, but for things like Spot and virtually any robotic system in a manufacturing facility or a warehouse. If you want to do anything in real time, you need a really reliable, low latency, secure connection. So, without 5G, for instance, the robot would probably do its scans overnight. It would come back, and then someone would have to go into the robot, grab an SD card, put it in the laptop, upload it. None of that needs to happen when you have that private 5G network. It all happens seamlessly over the cloud, and it's set up to work natively on a system like that. In addition, it also helps with kind of the navigation side of things, so the robot's better able to localize in the space. And then on the drone side, if we do have a misread of a barcode or a QR code, it's bound to happen. Using the 5G in real time, we can go back and make that correction, so we can ensure an even higher level of inventory accuracy count. And then not to mention, you made a great point about the scalability of 5G networks. So when that's present, the roadmap for our solution is even longer. So we could offload a lot of the compute from the system to the cloud because we have the reliable connection in real time. And that would ultimately increase runtimes and improve performance.
Super good. I don't know, maybe you can share already now some of the feedback that your customers have given you, even anonymized, or I would assume it's overwhelming, fantastic.
Yes, yeah. We don't have customers on the panel, unfortunately, but so I'll say, with prospective customers, everyone can kind of see the value in using drones for inventory counting, right? You can get up really high, you get the best vantage point of the barcodes and the QR codes, but they've heard stories of companies trying to implement this and, being rather unsuccessful. And the reason that was the case, though, is these drones only really fly for 10 to 15 minutes, right? They're very computationally intensive. But that's why we've paired it with the AMR. So the AMRs, has a powered tether up to the drone, and we've had about 5 to 6 hours of uptime when we're doing the cycle counting. So we can cover, a really significant portion of the warehouse's square footage in that sense. And then in terms of our customers in the field today, we find that the customers either fall into one of two buckets. They need the 95 to 99.5% accuracy, but they got a lot of temp workers, a lot of turnover. So we're able to maintain that accuracy and kind of solve that problem for them. And then you have the other bucket where folks are around the 75% range, and a lot of cases it's an all hands on deck. Everyone's coming out to count inventory, but the employees hate it. It's a terrible job. So having the system come out and do that gives them, one, a higher level of accuracy, but two, also a lot of these companies are bleeding cash just because of inventory shrinkage. So being able to solve that problem for them as well is great. One of our anchor clients is one of the biggest retailers in North America, and we're in the field with them virtually every day, just trying to perfect this solution as much as we can. And they've targeted 300 units across their variety of locations. So that goes to show just how impactful this technology has been for them.
Wow, that's really cool. I mean, these were two perfect examples showing how technology, innovation, and creating value can go together, I think. And I think it also gave an impression on how do I get started with autonomous things. Sometimes it's just like taking the challenge and working on it, finding the right technology, because the right technology is there. I think we're almost done here, but I would ask for closing remarks, starting with you, John, maybe?
Sure. So taking a big step back, right? I think when you're trying to solve big problems like how to inspect equipment or keep people safe or manage large amounts of data, there is a big element of creativity that's involved in trying to come up with a solution like that. And one of the most important things that we think, again, we work with a lot of customers at Slalom to try and solve seemingly impossible problems, but one of the biggest areas that we think is critically important is having flexibility and allowing for creativity to come into your thought process is absolutely critical for this. This is why having a platform that allows you to basically do anything that you want, but then also has the technical capabilities to manage interactions with other systems, that's first and foremost, number one. Number two, this isn't science fiction anymore, right? These things are here today. And so I encourage everyone who has a problem that they're working on, either in your factory, on a production line, at an airport, at a train factory, wherever, is don't be afraid to start a project that includes AMRs, and especially now that 5G can bring all of these components together, now's the time to do it. The third thing I would say is find the right partners. One of the things that I thought was amazing about the work that we did was we had such a good collaboration with Ericsson and with Hitachi on solving a factory of the future problem where we were doing these very complex inspection use cases. These aren't things that one company could probably just do on their own exclusively. Like, having the right partners is absolutely key in this. So I would say those are the three things that if you take away anything from the talk around the factory of the future and what's available today, is those three things. The network is there. As long as you have room for the creativity and you bring products into the mix that can absolutely have the flexibility to solve these big problems, you'll be able to do it.
Perfect.
I'll just tag on to what John was saying, specifically about partnerships, and also, kind of where do you get started? I think that's probably one of the biggest challenges, is you see what the problem is, how do I tackle that? And so partnerships are really useful for that, because, and especially if you have the right partners, like Hitachi and Slalom in this case, where everybody's bringing different perspectives on the problem, together. And that really is what unlocks the creativity in terms of how do you approach this. So I would say don't be afraid to get started. Just get going, I think is the biggest thing. And don't be afraid of partnership either. It's a little counterintuitive for us as big organizations to say, hey, I can solve this problem on my own. That's really not the environment that we're playing in these days, right? These are really complex challenges, and it requires, I think, partnerships to really go further and go faster, candidly.
I mean, I don't know if we said this out loud, but when we started this project, the original proof of concept we did in days. This wasn't weeks, this wasn't months, this wasn't a 6-month to a year project. We were able to prove out the use case in days. And I think that speaks to the partnership side of this. We all brought our expertise to a problem, and we were all solving it together.
Great. Luke, any?
Yeah, I'm going to double down more or less on what they've said. The technology is there, whether it's, from one of us or, one of the many exhibitors here, the technology is there. The enabling technology in 5G exists, it's proven. It's just a matter of overcoming the adoption hurdle, I would say at this point. And the reality is change is hard, especially in a warehouse. A lot of the times the process stays very stagnant for years. So, for me to see successful implementation, it requires some work up front to build a really strong business case. Think of the financial implications of downtime or better productivity of resources, the financial implications of downtime if you're trying to do something like preventative maintenance. All of that is extremely critical, and there's the legal side of things when it comes to safety. Understanding the cost savings there. And then also the brand identity is really powerful, like being forward-thinking, being innovative. Clients love to work with providers who bring that to the table. And then in terms of the rollout, coming up with a very specific set of objectives. A lot of people like throwing out the term proof of concept or pilot project. Pick a really specific duration that you want to achieve very specific milestones and get those down on paper and set a roadmap for what would deem that proof of concept or that pilot to be very successful, and then try to understand what are the long-term ramifications of adopting this technology. Like, how can the business evolve? What are the positive expected impacts of integrating new and innovative technologies like this? I think if the mindset can shift towards this focus in innovation, as a country and as a nation, we'll move along very, very quickly.
Perfect. Joy, running a factory at Hitachi?
Yeah, I mean, I think I couldn't agree more with my fellow speakers here. If you look at the industrial space, right, it's really challenging. There's a lot of problems, and on face of it, two factories may be vastly different, very different challenges. And dovetailing on what you mentioned about adoption, right? So what's really important for Hitachi and also many other manufacturers is scale. So we don't really want to come up with a solution which will work just for one assembly line in a factory. We want it to work across all assembly lines, or another factory of the same group company in another nation for that matter. And for this, definitely building the right partnerships all the way from data acquisition, connectivity, cloud vendors, and I would say partner not just in terms of solution providers. Even within a factory, if you speak to the CEO, he may have his objectives or what counts as success to him may be made different from if you speak to the line manager. So beginning of any such project, we need to get everyone on board, have a clear set of, as you mentioned, roadmap, what counts as success, and then have a phased approach where we take a set of solutions which are, have proven value and a proven scale. And I'm very happy to say that that's what we've been achieving so far, and looking forward to more. Thank you.
Perfect. Thank you all. And I must say, for me, talking a lot to manufacturers, it's always a pleasure to see these things really happen coming from theoretical discussions and piece-by-piece digitalization to such, I would say, lighthouse projects and lighthouse products, joining different technologies, being, for us as Ericsson, important, being based, showing the value of the 5G communication platform, and solving real-life problems in a very smart and intelligent way. I think we can open up for questions here, if any.
No questions. We did a great job.
It's lunchtime now.
Yeah.
You're real good.
While the mic is going around too, one thing that I would just add in, part of this is also, having a chance, sorry I hijacked you there, but part of this is also getting a chance to talk to the people who actually do the real work.
Right.
So Alex and Jenna here, they're probably going to hate me for doing this, but they're the ones that were working with Spot at the factory. So if anyone wants to talk about that component of it, stop by the Ericsson booth, because Spot's going to be over there later today, well, right after this talk.
Yep.
And you can ask detailed questions about how this all works in the meantime. But sorry.
Yeah, maybe this is very question related to the integration aspect of it for Joy, for the future that we are talking about is already here, right? So the technology is there, but what I'm hearing right now is, it's a compute intensive aspect of it, but how do you manage the infrastructure needs? I mean, there must be something that should be thought of or planned of in terms of the infrastructure that should exist at the edge within the factory, maybe on the cloud. So how do you manage those priorities? What should be the approach to that?
You want me to?
This is a question for Roy.
Yeah, that's a great question. And that ties into my point that what we do, we don't want it to be just a POC. We want it to be, at the end of the day, adopted by the factory as a whole. And so one of the main things we do at the beginning of any such project is carry on an assessment to find out exactly, as you mentioned, what's the infrastructure out there, what's the readiness in terms of their data. And more importantly than from technology, it's more like the operational readiness. For example, taking the use case of Spot, right? So we don't want it to be just a piece of technology. We want, for example, factories have already, they already have existing systems which carry out inspection. There is inspection reports or set out tickets for maintenance. And these are all legacy systems. We want those systems to be integrated with this piece of technology, that the initial inspection request comes from a piece of software which is already familiar with the people in the factory. And also the end results of the inspection result in some kind of reports which can integrate with, let's say, the MES system in the factory. So those kind of integration is very important, which we do. And if in process we see that there's some kind of lack, then we would, of course, give recommendation. But that would be my answer.
Can I add something?
Yeah.
Yeah, I'll say another piece of it too, as the providers is accommodating to the existing infrastructure and systems. So, we had one client, for example, that had done a great job doing RFID tags on a lot of their inventory. So instead of, leveraging the drone, we swapped out the drone crown for an RFID crown. And then we went around the showroom floor scanning RFID tags. So I think the onus is also on the solution providers to accommodate to some of that existing infrastructure and, integrating properly into the existing ERP or WMS system that's there.
Perfect.
I'll throw my 2 cents in just real quick on that
Any
too.
other questions?
Just real quickly on that too. To answer your question very specifically, I think when we were working on this project in the factory, there was an opportunity. We started actually with more of a question, like how can we create the factory of the future? And when you take that approach, then some of the infrastructure needs become apparent, because then you start thinking about, well, wouldn't it be great to do autonomous inspections around these dangerous items without putting people at risk. And so when we first started out, we weren't really talking specifically about Spot. We were talking about using robots to do it, but that started building the question set for us to start thinking about, okay, if we were to insert Spot, which has the ability to run compute on the edge, like, you know, it has its own compute. But that's a trade-off with battery life. And so when you start making those trade-offs, and some of the missions that we were running were extremely complicated, right? Very, very intense for battery power and compute. The decision from the infrastructure piece to offload that compute across the network, across the 5G network, to a place that could actually process that compute was part of the design process. And so that actually was part of the reason why, I mean, we had the luxury of actually building the factory of the future. You know, it wasn't like a retrofit where we had to go and have a discussion about like, okay, well, we're going to kind of replace this network with that network. I think that's key, right? So again, it goes back to a little bit of creativity. Like when you start dreaming big about these use cases, that will dictate the type of infrastructure that you're going to have.
Yeah, just to add on to that, I mean, it really becomes the technology is in service to whatever it is you're trying to do, not the other way around.
Right.
Right.
Great. Any more questions? Okay, that's great. Thanks a lot to our podium here, and it was a pleasure to have this session together with you and the audience. And I would invite and encourage the audience as well. Ericsson has published a number of papers on these topics, on autonomous things, analytics, and industrial IoT that can be downloaded from the Ericsson website. You can also come over to our booth, pay a visit to Spot and the people here on stage. Have a great rest of the show, and thank you very much.
Thank you.
Thank you.
Thank you, Jan.
Good job, guys.